over these, then the faster you can look at your yearbooks. All right, so remember, some of these are little simple things, but you have to remember like the difference between certain things, and these are great 2-point questions of the multiple choice. Identifying the population versus the sample. Remember, the sample is a subset of your population. You always ask yourself, are there more than this? So for instance, a study of 254 patients with sleep disorders. I say to myself, are there more patients with sleep disorders than 254? Yeah, so this is a sample. It's coming from a population of everybody with sleep disorders. Okay, and only the sleep disorder people, not every person. So always ask yourself, is there more? If there's more, you got the sample and look at the population. If you looked at your notes, we went through 4 levels. We went through nominal, ordinal, interval, ratio. Marissa, come on, get your stuff out. Interval, these are great 2-point questions. You don't want to lose your points on the multiple choice.
Can you go over like the difference between interval and ratio?
Yes. Interval says there's some kind of difference, like temperatures. Temperature time is interval. Think of when you call it a time temperature, but think of like something like that. Time temperature interval. So interval says yesterday was 85, today is 80. I can know that there's 5 degrees difference. It's a little cooler today. Can I say it's twice as cool? Or it's a third as hot? I can't make a ratio in that temperature, but I can say it is 5 degrees cooler today, 5 degrees warmer yesterday. So I can make some kind of a difference, but I can't say twice as much, a third as much. A ratio means I can say half, twice, something like that.
I'll come back with more things.
Oh, do you need something?
That's okay. I'm looking for Will Banker.
Oh, I don't know what happened to him.
Okay, thanks.
Yeah.
Thank you.
I don't know what happened to him.
Yeah, thank you.
All right, so that is the major difference between these. We talk about the zero. The zero is a time or is a degree. It's not inherent. Inherent means there's no books, 0 books. But a 0 temperature doesn't mean there's no temperature. It means that is the value at that point, 0. And the time is considered 0. But doesn't mean you have no time, really, as you're starting at the 0. But how I would say it is a ratio, if you could say twice as many, half as many, a third as much, that's your ratio. That's your highest level. Remember, ordinal, put some kind of order out there. Least to greatest, compact to SUV. Some kind of order. Nominal, it's your name. It has no bearing on that. Think of the number on the back of your shirt. It doesn't mean you are 12 years old. It doesn't mean you are the 12th person on the team. It means your number is 12. And they yell out, "Hey, number 12." Okay? We also had data collection. We had experiment. We had surveys. We had 4 of these. It's on your thing. An experiment is the one that you usually have like a control group and a non-control group, like the placebo type effect happens in there as well. It's all like that part's in your notes. So if you're going to study the stimulation is in here, because sometimes it's not a good idea to do things. If you're going to study the effect of a low dietary intake of vitamin C and iron on lead levels in adults, you can do an experiment as long as you're not harming them. If you're taking something away from them that's going to harm them, then you're going to do a stimulation. So if in fact you're going to take away their vitamin C and their iron and you're going to watch them deteriorate over time, then don't do that. If you're just changing something, their diet, and you want to see what happens there, as long as it's not harmful to them, you can do an experiment. Otherwise, like if you're testing the effect of radiation, of being exposed to radiation, you certainly wouldn't want to take the chance of exposing anybody to radiation or exposing them to lead, something serious like that. So you would do a simulation. Sampling versus when we do the whole population census. Census is your entire population. More times than not, it's almost impossible to do a census because you can't reach everybody. Even our census that was taken every 10 years, they're now finding that by the time they do all this information and they process it, it's all obsolete. So they're coming up with a new way to do census taking because it's not really worth it to wait the 10 years and then figure out what your results were because you could have used it from the very beginning. So I think now they're like sampling different areas when they do census, and they still may do it every 10 years. I'm not really sure, but the information now is a little different. We had different sampling techniques. We had convenience, systematic, stratified, random numbers, and one more. Cluster. Thank you. And one more. Cluster. Convenience, that's the one that has bias. Thank you. This is the one that has bias. This is the one you want to avoid. You know, asking your friends to complete your survey about what kind of music they like. Asking your friends to see like what kind of courses they would take in college. So you kind of want to avoid the bias part. You want to make sure everything is done at random, and all your sampling techniques will say at random. It doesn't mean that that's the random number generator one. It just means they all have to be done at random. Every fifth engine part, there's your systematic, like in gym. Counts off 1, 2, 3, 4, 5, all the ones, all the twos, all the threes. A study on attitudes about smoking is conducted at a college. The students are divided by class, freshman, sophomore, junior, senior. And some are selected, a sample selected from each class. How is this different than cluster? How is a stratified different than a cluster?
I think with the cluster, they just like naturally fall into this group. It was stratified, like you put them in the group.
No, they naturally fall into freshman, sophomore, but here's the difference. A stratified says a sample from each group. So I want, in my sample, I want some freshmen, some juniors, some seniors, some sophomores. A cluster says, out of all those 4 groups, give me all seniors. Give me all of one area. Out of like zip codes is another one. Out of all the zip codes, I have 12550 for Newburgh. I have 12553 for New Windsor. So give me all New Windsor. Not some of Newburgh, not some of New Windsor. I want all of New Windsor. That's cluster. Stratified is a little bit of each. Think of like, I always think of a stratified rock, how it gets compressed by layers. You take some of each kind. Okay, here was the big one. The part with all the graphs. The most important part to this is making your class limits, finding your class width, and you are going to have to do this on your test. So I'm going to give you data like this, and I'm going to tell you how many classes to make. I'm going to tell you how many classes, just like this does. So you're going to take the max entry minus the min entry and divide by the number of classes we need. This is going to give you your class width. Always round up. We round up because if we round down, there's a possibility that we could miss that last number. And you begin with your lowest one. So when I go to begin my chart, I say, start with my lowest entry, 101. This is where my class width is. Add 12, add 12, add 12, add 12. And just go like this. The number before 113 is 112. The number before 125, or just on this side, add 12. If you count 101, 102, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You have 12 entries in that level. There's always one more than you subtracted from. So make your class width go this way. This is extremely important. Now, your midpoint and midpoints are great to use in any of your graphs, except the ogive. The ogive says use an upper class, and we'll talk about that in a second. The midpoint, add the two together, divide by 2, and then just add 12 all the way down. Your class width is 12 apart. Your boundaries say, if I made this line and this said 101, this said 102, all the way up to 112, 113, my bar would have to go like this. I want my bars to touch. So your boundary extends it that half. It's kind of like that little air conditioning unit that you stick in the window. And you pull out the sides just so that it meets those corners. So it's extended. So we subtract 5 from the lower end, we add 5 to the upper end. That's how you get your class boundaries. Your frequency, do your tick marks. Tally them up. This total should be the same that you had up there. How many did we have? 25? Is it 25? Yes, 25. So that total should be the exact same that you counted. If you don't have that total, don't do anything else until you figure out what went wrong. Relative frequency, God bless you. Part over whole, 3 over 25, 11 over 25. You can go to decimals. Cumulative frequency, this makes your ogive graph. Start at the smallest, add the next one. 3 plus 11, 14 plus 7, 21 plus 2, 23 plus 2. This number has to be your maximum amount in your data. That's the most important part of setting up this table.
So the cumulative frequency, why did you put 14 after you?
Because we started with 3, and then the next interval added 11. Then we added 7. Then we added 2. Cumulative means keep accumulating. Like, take your first 3, put it in the basket. Take your next 11, put it in there, you now have 14. Take the next 7, put it in there, you have 21. Take 2 more. This means keep accumulating all your... Good. You're going to have to make a table and one of the graphs. Which graph, I don't know, but you'll have to make one of the graphs. Can everybody do this part? This is the basic part. You have to be able to get that part down. From there, you're going to make your graphs. Midpoint, you can use midpoint on most of them. I happen to like the midpoint rather than the upper class boundary, mostly because when you make your frequency histogram, it's a bar. When you make your relative histogram, then that's a bar as well. When you make your frequency polygon, it's a line graph and it comes in the middle of your bars. It takes the midpoint. So you might as well just use the midpoint. The relative frequency, the regular frequency will have the same look, the same bar to them. We'll just change the y-axis. But the frequency polygon will have the same look. It'll just bounce off the middle of your bar. So I like to use the midpoints. I think midpoints is easy. Don't forget a title. A title and a label. Title and labels. Label your axes. Okay, I used midpoints. Now, ignore the red right now. The blue is the frequency histogram. The blue is your basic graph. The red, I put it on the same graph, is my frequency polygon because we use the midpoints. So the red guy is my frequency polygon. Now, notice what would happen. If I just started here and I connect my midpoints, I'd be here. I'd be sitting in the middle of my graph. It has no beginning, it has no end. So we're going to drop this down and drop this down. This one, just subtract 12. Give me the midpoint before it. This one, just add 12. Give me the midpoint after it. It just makes it aesthetically correct, I guess. Your relative frequency, look, it has the same bars, doesn't it? Same shape. All we changed was your y-axis. Make sure that you space these equally apart. Don't go from 2 and then do a 6 and then do an 8 and then do a 12. Make sure they're equally spaced apart. I'm not grading your exams, so you have to make sure everything's looking good. I give them a rubric to grade off of. So if that's not there, you're going to lose a point. Frequency histogram 2, think money. This is my 0. I went by 8 cents. Think money. You can go by 2 cents, by 5 cents. I obviously didn't leave myself a lot of space, just so I could just put the graphs out there. This is your ogive. Remember, all of them get titles. It's all the titles are times to exercise. I just wrote one title for all of them. But now, look, this is my cumulative frequency. I'm using my last column, this column. In this guy, this needs an upper class boundary. The only one you have to add is 1, because here starts your ogive, up here. They're line segments. Don't make it smooth. These are line segments. But drop down 1 class boundary. Leave it hanging up there. That shows growth. If you bring it back down, then you lost everything. So leave it hanging up on the right-hand side. Everybody remember your box and whisker? Your 5 summary numbers? Okay, so what you're going to do with your box and whisker is a little bit different. You're going to go back to your numbers. You're going to go back to your entries. You're going to put them in your L1 on your couch. You're going to do L1, edit, put them in edit, then do L1 calc, you do stat, edit. And you're going to do 1 var stat. Scroll to the very bottom. The very bottom is what we call the 5 summary numbers. The 5 summary numbers are these guys. They're, as soon as you scroll to the bottom, you'll get a min, you'll get a max. It says it just like this. It says quartile 1, 117.5. It says quartile 3 over here, 131.5, and in the middle it says median. But median is at your halfway mark, your 50, which is 2 quarters. 2 quarters is worth 50 cents. Think of money. These are called our 5 summary numbers. Use that, make a number line, plot your 5 critical numbers, the whiskers, and the box. Don't forget a title. Does anybody remember how to find the interquartile range?
1 minus 3.
Wait, something minus 1.
Yep, 3 minus 1. The only 2 quarters you see out there. That's what's nice about this. Quartile 2 is your median, but it doesn't say quartile 2, right? So the only ones we see are 3 and 1. So quartile 3 minus quartile 1. Kind of is a nice little way to look at it. You don't have a lot of use for a box and whisker. I don't even know why they go over it, but they do. You could actually kind of tell where's the concentration of your data and which ones are not as consistent. Each one of these parts represents a quarter of your data because it's set up in quarters. But what does this mean when that section is longer than the other ones? What does it tell me about the data for that area?
Skewed.
It's skewed, but it's like not consistent. It's more varied, more varied in between.
It's non-uniform.
It's non-uniform. Well, non-uniform, it could be any of your data, but like this data right here is probably closer in numbers. Like I have more 121s, 122, 123s. Out here I probably have a 140, 156, a 160, a 152. They're kind of spread out. They're not as consistent. Good? circle graph. I saw some of you struggling with the circle graph. Circle graph says part over whole. I want a percentage. So first thing you have to do is add up all the parts to this. God bless you. Add up all the parts to this. And then take a total and find me your percentages. So 14.1 over 77.9. Don't do angles, just do percentages. These percentages should add up to 100. If they don't, it's probably because of rounding. So make them add up to 100 if you have to. These actually add up to 100, so we're good. Now, when you do your circle graph, easiest way is to section this by every 25%. So start with one that's easier, 21.7. It's a little bit less than 25. Maybe I want to start with this one. This is my equipment. Put it there and put the value 28%. This is a little bit more than that. Sorry about that. It's a little bit more than that. And it's got to be reasonable. Keep track. If this is 25 and you use 3, then you're going to have 22 left. So just keep track so you get a placement. 41, probably a good chunk over here is 41. And then separate these so that you get an 18 and a 13. 13 obviously has to be smaller than the 18. So just keep track of those. I don't want to see like, this is 41%, this is 13%. I don't want to see this. No one's going to measure it, but I need to eyeball it. Give it a title. Make sure you give it a title. Make sure you put your percentages there. Do they have to be in any special order when you put them down? No. Whatever ones you find first. Do they have to go straight through the bottom? No. Pareto goes highest to lowest. You can touch the bars or not touch the bars. Your x-axis has nothing in common. So there's no continuity in your x-axis. I know the book sometimes says separate them, and sometimes they use them together. I happen to like them together, but whichever way you want to do it. This is, what level of measurement is my x-axis? Nominal. It's just a name. And what level is my y-axis? A ratio. I could say one is twice as expensive as the other, twice as much money spent, half as much money spent. I can still say minus, but the highest level means I can say half spent, more spent, most. This gives you some kind of order, highest to lowest. So if you're looking at this and you're seeing where do you spend your money, you might want to see like what I need to change, what I need to invest in, what I need to look at. This works real well like for when businesses are losing money, like where are they losing it? Sometimes vendors make mistakes. If you find you're getting pilferage from vendors, then definitely change your vendors. So this kind of gives you a quick look. If you see shoplifting is high, then work on getting a security guard in your store. So this kind of tells you at a glance, what do I need to address? What can I let slide a little? Are we good with the graphs? Because you are going to see at least one, maybe a little bit more in the part ones on some of those graphs. And the part 2 is you're going to have to give me a table and at least one of those graphs. So we're good? I know this kind of brings us back to probably September, October. It feels like this course was so long when I say back in October.
It is long.
It's almost done. It's almost over. Yeah, everybody can't wait to get out of high school, but then when you get into the real world, you realize how much easier high school was. It wasn't so bad anymore. When you get into the real world, well, you still look forward to summer vacations. You don't get summer vacations. Especially when you go to college, I always found that going to college is a little bit more stressful during the in between. I worked 2 jobs. Yes, but don't forget, you're gonna have to make some money somewhere along the line, so you're gonna be taking those times off trying to find jobs. And in the summer, I ended up always working 2 jobs. so I could save up enough money. But
It almost feels like our year is too long.
our year is long, but if you kind of think about it, in college it's really kind of condensed. It's really like two little sections of school. Your first section done, second section done. So you kind of have nice closure to it.
I have like a lot of college friends, and they told me that college is better than high school. It's like
Oh
the
yeah,
workload, not the workload, because there's a lot of work involved.
yeah,
They say like the environment's better. And
oh yeah,
I'm like,
yeah.
it's just they tell me it's better.
Oh, it totally is. And they say the friends you make in college are the friends you make for life because you're with those people all the time. You're like with that same little crew that you kind of travel with. But what I'm saying is, like, when you go into the work world and you say, oh, I can't wait to get my summer off. People say, I don't have summers off anymore. Yeah, yeah. Okay,
You guys,
so.
you just best job out there. Is that what you're trying to tell us? You the best job out there? Is that what you're trying to say?
No, that's not what I'm trying to say.
That's the opposite, right?
She's not always the best job, and I always work summer school.
Oh, really?
Yes, we can, Mercedes. Okay, popular demand, 7, 8, and 9. Okay, now this brings us back to your empirical rules. Your empirical rule, which I gave you on your notes, say plus or minus 1 standard deviation, 68%. Plus or minus 2 standard deviations, 95%. Plus or minus 3 standard deviations, even though it's 99.7, they just round it off to 99. They don't want to say 100 because 100% would mean everything, and it's not everything. Now, easiest way, put your mean in the middle, lay out your 1, 2, 3s, and take your standard deviation, add it, add it, add it. Subtract it, subtract it, subtract it. So now, you had to know that 95% of your data falls between plus or minus 2 standard deviations. What are those values? This and this. But you kind of have to know something about your empirical rule because I don't give you a chart with all the percentages. As a matter of fact, Algebra 2 on the Regents Common Core does not give you that graph anymore with the percentages. They also have to know empirical rule. These guys, basic z-square formula. I will give you the formula. I don't divide by the square root of n because this is my population. If you took out the one that says divide by the square root of n, you'd say, what is my n? So therefore, there is no n. This is your population. This one goes way, way, way back to the basic part. And so we compared it to see where they were. Something with 200,000 falls right here. We can see that that z is equal to 3. We can see an x of 200,000 gives us a z-square of 3. But the formula proves it too. 55, whoa, that's very unusual. That's out here somewhere. Remember, anything plus or minus 2 standard deviations is unusual. Anything plus or minus 3 is very unusual. Those are our big fancy words. So be prepared. You might get a question or two that gives you a very simple z-score. I always find it a little harder to give a simple question because you're looking for a heavier duty question. Did we go through this one?
Yeah.
We went through this. Can I move it up?
Yeah.
And we went through the next chart, right? Okay.
Can I just see like a couple of the first answers for the number 9?
Sure. Yep. Yep.
You have to state it was very unusual.
Huh?
You have to state it was very, like very.
What do you mean?
Unusual.
Unusual? That's all. Very is 3. What's minus 3? How do you distinguish between 2 and 3? You still think it's unusual, unusual?
Yeah.
Yeah. 3 is like, 3 technically covers 99.7% of your data. So you're less than 0.3 in both tails. So you're less than 0.15% in one tail. Okay, and number 9, remember, work your given. Whenever you have your given, you circle the part that's a female. Don't come out of there. If it's not a female, what is it? A male. Circle the male. Don't come out of here. These are mutually exclusive. When they're mutually exclusive, on an or, you add them. Given. The male. Don't come out of the male area. Earned a bachelor's degree, that's asking anybody, regardless, male or female. Come across to your bachelor's, take it over the total. I know we went through this just to go through it a little bit more. This one too, guys, be careful of this one. This has an overlap. This is a female who has a master's degree. If you looked at a Venn diagram, this is kind of like a Venn diagram thing. These are the people that have master's degree. These are the females. And these are the ones that overlap. They're the ones that they have in common in your Venn diagram. So it's really kind of not like that different. The and, just go right to the one that they have both. You could do the multiply one, but it's easier to just go with the one that is the both qualifications. And this given, I switched around and had given that they had this degree. Yes.
And usually exclusive, right? You have to
This one?
Yeah.
No, did you leave it as a fraction?
Yeah.
Just make it a reduced fraction then. Just reduce it to lowest terms. If you're going to put it in your calculator to reduce to lowest terms, you just might as well flip it to a decimal. Whatever you find easier.
Can you keep all of them in the fraction or do you have to?
No, as long as you keep them as reduced fractions. So that's why I say